You can think of this lesson as Graphing Polar Graphs, Part 2 or Day 2. And according to the Desmos activities, you were graphing what was called limicons. Okay? And limicons have a very specific form. It's either r is equal to a plus or minus b cosine theta, and r is equal to a plus or minus b sine theta. So anything of this form is not a rose, it's going to have what we call a limicon. So the process for graphing this is pretty much you need to plot the poles. As usual, the poles are a very important aspect of polar graphs. And then basically you just plot theta equals 0, pi over 2, pi, and 3 pi over 2, sort of the main axes. And that should give you a pretty good idea of the graph, okay? Let's take a look at an example of a limicon. Something like this. R is equal to 2 minus 4 cosine theta, okay? And what's important again is to find the poles. The poles occur when r is equal to 0, so we just need to find the angles where that occurs, right? And that's pretty easy. 0 equals 2 minus 4 cosine theta. I can solve for cosine theta. Cosine theta is equal to a half, and we all know that cosine theta is equal to half at two locations because of our superior trig knowledge. That occurs at pi over 3 and also at 5 pi over 3. So using sort of these key points, we can make our r theta table, okay? So with these key points and the pole. So in order, the first one is 0. Then comes the pole, pi over 3. Okay, then the rest here, pi over 2, pi, 3 pi over 2, and lastly is that last pole at 5 pi over 3. And of course back to 2 pi, but we don't need to plot that, okay? So we know the poles are 0 at those poles, okay? When theta equals 0, if you plug it in, cosine of 0 is 1, so 2 minus 4 is negative 2. Pi over 2, cosine of pi over 2 is 0, so if you plug that in, that's going to give you 2. Cosine of pi is negative 1, so it's going to be 2 plus 4, which is 6, and then if you work it out, this will be 2. So let's plot those 2 points. 0 degrees points this way, but I go negative 2, so I'm going to be here. Then I'm going to have, in the pi over 2 direction, will also be 2. In the pi direction would be 6. 1, 2, 3, 4, 5, 6. Uh-oh, I'm a little bit off, but that's okay. And then it's 2 here. Okay, so what's the path? So the path has to be counterclockwise, and it has to pass sequentially through these points. 1, then 2, 3, 4. It has to pass through that way. So here's what I'm going to do. I'm going to go counterclockwise. I'm going to go from this point to the pole. I'm going to try to enter the pole so I'm tangent to that line or parallel. Okay, now the common mistake students make is when they go here, they go kind of straight to there, which is fine, but then they do this, and that doesn't look right. So what you actually should do is go a little bit past that point to give it a little bit of roundness. You want to be flat there, okay? That's point number 3. Then I need to get to point number 4, which is really just a reflection. This is going to be a little bit difficult. Try to make it as nice as possible. Okay, there's point number 4, and then the next one is 5 pi over 3, so I need to enter the pole. I'm going to try my best to be tangent to that, and then background at 2 pi, like that. Okay, so that is our limicon. Let's take a look at a second example just to see what sort of things could possibly happen. Okay, so here's a situation where if I try to find the poles, right, and I set this equal to 0, something strange happens. Okay, we get cosine of theta is equal to negative 3 halves. Well, cosine is never bigger than 1 or less than negative 1. So this has no poles. There's no solution. It never goes to the origin. So how should we go about drawing this? Well, we can still set up our r theta table the same way using our key points, but let's sort of see and explore what happens in this situation. And because I have space here, I'll put 2 pi. Okay, if I plug in 0, cosine of 0 is 1, so this is 5. Pi over 2 gives me 3. Pi will give me 1. 3 pi over 2 will give me 3, and then we're back to where we started. Okay, so here's your key points. At 0 degrees, I'm at 5. At pi over 2 degrees, I go 3 steps up. And then at pi, I'm 1. And then 3 steps over here, okay, and then back around. So how should I draw this? Well, I'm going to do the same thing. I'm going to kind of draw a pretty big loop, go up and over just to give it a little bit of roundness before I come down. Now, what happens here is a little bit of debate. We'll talk about how to find that. Sometimes there's this little dimple there, okay? So how in the world do you know if there's a little dimple or not, or if it's just sort of egg-like shape, okay? So here's how you're going to need to determine, okay? We need to find vertical tangents in order to determine how many, if there's a dimple, okay? To determine if the graph is dimpled. Well, why is that? Because if you have 1, 2, 3, 4 vertical tangents, then there most likely is a dimpled graph, okay? If the graph was not dimpled, I'll draw it here in green, if the graph just kind of looked like this and just went through the points very cleanly, you would only expect to see 1, 2 vertical tangents. Okay, so all of those we need to kind of take in consideration. But in order to determine how many vertical tangents there are, guess what we need? That's right, we need calculus. That's the one thing we have not done yet in terms of polar equations. So let's get to it. The first thing we want to do is think about what is the interpretation of dr d theta. Okay, dr d theta is the rate of change of r. So what does that mean if it's positive, and what does it mean if it's negative? So it's a little bit nuanced. Okay, so here's how to think about it. Okay, if r is positive, okay, if r is positive and dr d theta is less than 0, what that means is you're shrinking, is you're moving towards the pole. Okay. Your r is a little bit less than it was previously, okay? What if r is positive and dr d theta is also positive? Well, that means you're growing, so you're moving away from the pole. Okay? I'll let you think a little bit about the situation where what happens if r is negative. Okay, so it's pointing the other way. Okay, so I'll give you some time to kind of think about that on your own. What we're actually interested in is we're actually interested in finding dy dx, the slope of the tangent line. So dr d theta, dy dx, those are very different things. Okay, so in order to do that, we need to remember something. We need to go all the way back to parametric equations, or the conversion actually. So remember that how we converted x from r and theta is r cosine theta, and y is r sine theta. Okay, so what we have in polar is r is actually a function. So it's r of some theta, cosine some theta, and then r some theta, sine of some theta. Okay, so let's see it in action in our particular situation from above. Okay, if you remember this problem here where it was 3 plus 2 cosine theta. Okay, so for example, if r is equal to 3 plus 2 cosine theta, how do we find derivatives? Okay, well, x is going to be equal to 3 plus 2 cosine theta, right? That's your r, cosine theta. And y is going to be 3 plus 2 cosine theta, sine theta. Okay, so now it's actually a set of parametric equations. We know how to find dy dx then, right? So dy dx is just equal to dy d theta over dx d theta. Okay. There's going to be some crazy formulas you're going to see online or in your textbooks, but essentially this is what that formula comes down to. Now, obviously, there's some product rules and things like that. It's sort of a bit of a painful process, but let's maybe take a look at x. Okay, so if x is, if I multiply out 3 cosine theta plus 2 cosine squared theta, I can get dx d theta. Okay, dx d theta, if you work it out, is going to be negative 3 sine of theta minus 4 cosine theta sine theta. Okay, and that's going to go in here. Now, the reason why this is probably good to know is, what if I'm interested in when this is equal to 0? Well, if this is 0, then the slope becomes undefined, and we can figure out how many vertical tangents we have, right? So I can solve this pretty easily if I factor out a sine, and that leaves me with negative 3 minus 4 cosine theta equals 0. Okay, this right here, this is easy. Theta is equal to 0 in pi. And this right here, if you work it out on your calculator, theta equals to roughly 138 degrees and 222 degrees, meaning what? There's 4 vertical tangents. There's 4 places where dx d theta is 0. There's 4 places where the slope is undefined. And so I can see that this is correct, right? And let's see if we're even close. So 0 and pi, sure enough, it's 0 vertical, at pi vertical, and then 138 and 222. Yeah, close enough. 222 there, 128 there. So not a bad guess.